Everyone. Today we're going to talk about three experiments that I've tried to replicate from the paper about seam carving. Uh, Seam removal. If one wants to reduce the size of an image from either the width or height, they would identify low energy points in the image, which are called seams, and remove them, thereby reducing the size and also losing the least amount of information. Uh, the algorithm goes as follows. We first create the energy image using gradients and this equation. We start off from the lowermost row, find the appropriate neighbors that a transition can happen, find the appropriate energy values and select the one with the minimum energy value and update according to equation 2. We keep moving upwards until we reach the topmost row, after which we find the index with the minimum m value and backtrack from there. The results from this process are pretty similar to that of the paper, where the seam removal works the best, followed by scaling and then cropping. Cropping loses some content in the image. Image retargeting. This is where we want to change two dimensions in the image. Um, and the algorithm is similar to the dynamic programming approach in step 1, except we also maintain directions that we have to take in order to find the best order of seam removal. The results are slightly different from that of the paper because I think I chose a different target size. However, the image retargeting still performs the best, followed by all vertical or all horizontal, and the last was alternating seam removals. Finally, we move on to seam insertion. This is where we want to enlarge an image, and in this case, we wanted to enlarge the width. We do the same steps as seam removal, except instead of removing the seams, we add them. One issue that I had found here was that the seams all had concentrated on the left side of the image, and I needed to offset them based on the logic I mentioned here. That was the most difficult part, also reducing the time taken to uh, conduct the experiment, which I did by introducing vector implementations instead of loops. That's it. Thank you so much.